right, Lola, were you first? Oh, Lola's first. Well done, Lola. Hey, Toby's here. You got 2 minutes, Lilia. Can you name those chemical reactions for me? Oh, Chris, it's your birthday tomorrow. Amazing. Oh, happy birthday for tomorrow. How old are you going to be? Lilia says the candle, the dog, the rotting of broccoli. Nice, and lemon juice. But what about the lemon juice, Lilia? Is lemon juice a chemical reaction? Come on. This is great. I love hearing your brains think. Yeah, Jemima, malt's okay. Right, what time is it? Oh, we're nearly there. It is 1:30. Thank you, Sharon. All right, let's go. Hello, and welcome to this science lesson on chemical reactions. How many of these chemical reactions did you get? So Lilia was doing a fantastic job there. Did everyone get the dog? Now, if it was an exam, just saying the dog would not get you a mark. What is the dog doing, which is a chemical reaction? I'm going to pan out a bit. The secret is revealed. I don't have one of those phones that shows things the right way around. Hello. Should we go through those answers? The dog is breathing, respiring, making oxygen bond to other things and breathing out carbon dioxide, just like thee and me. So that's chemical reaction. The candle, well done. If you've been to any previous lessons, that is a combustion reaction happening there. Paraffin in a candle. Oh yeah, Abby says the dog is walking. Nice, yes, using energy to walk, exactly. So chemical reactions happening all over the body. Combustion reaction there, paraffin is reacting with oxygen to produce heat. Lilia, you said lemon juice, fantastic. This is why I love my comments. That I think this orange or lemon or whatever it is sliced in half is a chemical reaction, but what is actually happening? Did someone say rotting? Yeah, so instead of rotting, we could say oxidation. So you know how like if you bite into an apple, it goes brown really quickly? That's because oxygen in the air is reacting with the fruit, oxidising it, turning it into something different. So that is a chemical reaction too. Well done. Oh yeah, and there's a plant here. So photosynthesis. Deep on my YouTube page, I have got a video where I explain photosynthesis really well, I might say. So you can look at that if you want to know about that in more detail. But yeah, those leaves are photosynthesizing, sort of doing the opposite of what the dog's doing, turning carbon dioxide into the air into sugar. Right. Hello. Good afternoon. Welcome to the science lesson on chemical reactions. I am Lara from Theatre of Science. I'm looking a little bit like a goth children's TV presenter today, but we are going to do some quite deep science. Last week I showed you little particles all rearranging to make something new. That's what a chemical reaction is. So for example, here we've got something called methane, which might come out of your oven if you've got a gas oven, reacting with oxygen molecules. Don't forget oxygen, even though it's an element, because there's only oxygen in it, it likes to pair up as a molecule. And that becomes... Oh, spot the deliberate error from this physics teacher. It doesn't equal it, does it? They're not the same stuff, but it becomes carbon dioxide, and it also became some water molecules. Can you imagine chemists having to write out things like that every time they wanted to talk about equations? No, it would be awful. So, we also looked at this last week. A word equation. Much easier, isn't it? You just write methane gas plus oxygen becomes carbon dioxide and water. Even that is a little bit tedious. So we're going to see something even better than that in a minute. But first of all, I want you to try and do some of these. So this is an example of an oxidation reaction. Oxidation just means something is gaining oxygen. So what has been oxidised in this reaction when you burn gas? Well, carbon has been oxidised. Carbon's won some oxygen there. And hydrogen has been oxidised as well. So I'm just going to be a bit mean here. I'm going to throw you in. There you go. Oh, hello, Caden. Have a little go with those. Like I say, I haven't given you any clues, but what you've got to do is just fill in the gaps. So there's one gap there. There's two gaps there. And there's two gaps there as well. Brooke, age 8, hello. Oh, Brooke, let me know how you get on with this, won't you? You done those? I give you 5 more seconds. 4, 3, dioxide. I haven't given you any dioxide though, have I? I haven't given you any dioxide, Lilia. So you've got to use some of these. Shall I give you the answer? Hello, is that Fatima? There you go. Some of you might be thinking, oh, she spelt sulfur the American way. They changed it. Those science bosses say that we have to spell it with an F. Adults in the room, they might be thinking that it should be spelled with a PH because it probably was in your day. So well done if you got those right. Very well done if you got this one right. I was a bit tricksy there. So here you can see that the carbon has sort of stolen the oxygen away from the copper, leaving copper on its own and carbon dioxide. Quite a useful reaction if you want to get some copper. So this bottom one, you can see quite clearly that something has been reduced as well. So copper used to have oxygen, and on this side it doesn't have oxygen anymore. So when things gain oxygen, are oxidised, like carbon's been oxidised here, something is also reduced. So here, copper, we say it's been reduced. It's lost its oxygen. Right. Sarah, what are we doing? I just joined. Should we do a chemical reaction? You are going to need, if you're doing it with me, if you're not, you can just watch me. A bottle with a narrow neck. If you want to put a balloon on top, you might do. I'm probably not going to. Some bicarbonate of soda, or sodium bicarbonate. If you don't have any of that, I know some people are using baking powder. You can tell me what happens, if anything happens. And some vinegar as well. And all you're going to do is put the baking powder into the bottle and then put the vinegar in and then observe. Give me your observations. Now I have got some pretty flashy digital scales, so I'm going to put mine on some digital scales and we're going to observe them first and then a bit later on and see what we see. I did say that you can also use eggshells for this, and we're going to be looking at the chemical reaction behind that as well. So if you didn't have bicarbonate of soda and you want to use eggshells, then you can stuff those into your jar. I was going to use a spoon, but it's handily, it's quite lumpy, so I'm going to put my bicarbonate of soda in there like that. I'm going to use a lot because I'm the teacher. Now, like I say, if you've got a balloon, you can add some vinegar and then put the balloon on top and tell me what happens. I might do that later, I might not. Depends how much time we've got. So there we go. If you've ever made a volcano, then you might have done this already. In fact, if you want to do this twice, if you've got enough stuff, you could put some washing up liquid in it, like the first time or the second time, and note the difference. Okay, come down here with me. I'm going to put the vinegar in. Abby wants to use eggshells and bicarb. Yeah, I think that's a good idea, Abby. I was actually tempted to do that myself, and then I thought I'd better not because we won't be sure which one's reacting. Do it, just do it. Okay, here we go. So I'm going to put some vinegar in now, and if you're not doing this at home, you can observe what happens to mine. You ready? Observe means use all your senses, of course. Now, first of all, how much does that, what is the mass of that? 291.5. Can you write that down for me, guys? 291.5. So what are we seeing? We're seeing some bubbles. We are seeing some fizzing. What is fizzing? Bubbles appearing. Has there been a colour change? You could say there's been a colour change, haven't you? Because the vinegar is most definitely clear, and that is not clear. That is white. Rising up. Very good, Sarah. Yes, so you could say it's expanding. Hopefully you heard that delicious hissing noise. Right, so we'll leave that on the scales and then we'll come back because I want to talk to you about scientific laws. So if something seems to happen all the time, we say that it's a scientific law. So like famously, Newton came up with a beautiful equation to show the law of gravity, like how gravity works. You have probably noticed a scientific law already without really thinking out of it, because some of them are absolutely incredible, beautiful equations, and some of them are pretty obvious, frankly. So what do you notice about this? If you were going to come up with a law of science, what do you think you might be able to say? I'll show you another one here. There's another equation for you. Any scientific laws you could come up with? you might have noticed that all the particles on this side of the equation are still on this side of the equation. They're just in different places. So a chemical reaction makes something new, but no particles have been lost when the chemical reaction happens. And no extra particles have been added as well. That is a scientific law. It's called the law of conservation of mass. Mass just sort of kind of means how heavy stuff is, like how much of it there is. This is the law of conservation of mass. I'll show you an example. Again, some of you might be thinking, this seems pretty obvious. Well, that's good, isn't it? You know, if you ever sit and examine this stuff, then it makes sense. So, for example, if I was going to make a mixture of some conkers and some rice, just what I happen to have in the office, if you watch all my shows, you'll know why. So those conkers weigh 10.2 grams, all right? 10.2 grams those conkers weighed. This rice weighs... If I put the conkers and the rice together, what do I get? I get the mass of all of them together. Like, yeah, obviously, of course you do. That is the conservation of mass. Just to be absolutely sure that you yourselves have understood conservation of mass. Can you do those for me? I'll just give you a minute. Okay, I'll give you the answers to those. Esther, let's have a look and see if you were right. Yes, well done. 15, 20 and 24. Excellent, so everyone's got the hang of this. Yeah, the two numbers of the mass of the reactants has to be the same as, that does equal, doesn't it? The mass of the product. Well done. Why is dioxide for sulfur only? Ah, good question, Sean. We will get to that in a bit, actually. Yeah, we are going to get good. So Sean raises an interesting point. What you've sort of noticed is that these equations don't tell you everything. What they don't tell you is how much oxygen and aluminium and sulfur are reacting. I mean, obviously you've got the masses here, but usually this is word equations that we're looking at the moment. We are about to look at something else. The mass of our sodium bicarbonate and vinegar mixture was 291.4. So, according to the conservation of mass, we are going to see 290. What? Oh, shock, horror! Surely nobody saw that coming. How's that happened? What have we lost? We've lost 0.6 grams, haven't we? How's that happened? Guys, give me the explanation for that. So, we put some bicarbonate of soda and some vinegar in, and we mixed it up. Wouldn't you expect, because of the law of conservation of mass, that no particles had been destroyed or appeared, and that would be the same as it started? Why has that changed? Come on, somebody tell me. Ah, wonderful, Abby. Yes, I think you need to have a little word with your translator there. But yes, gas has been released, that's right. Let's have a look at what just happened. There we go. Just put those marshmallows out of the way there for later. So here we have acetic acid. So vinegar is quite complicated, but it's about 4% acetic acid, which is what's responsible for the beautiful reaction we just saw. And here we have some calcium carbonate, which is what eggshell is made of. So I'll do what would happen if you put an eggshell in vinegar. First of all, two hydrogen particles pop off the acetic acid and they react with carbonate. So this is calcium carbonate, but that gets separated to being just carbonate, and you get something called carbonic acid. So two hydrogen particles come off there. That calcium pops off and you get something called carbonic acid, but that is what we call unstable. It doesn't last very long. So maybe if you've been to some of these lessons before, you can see water and carbon dioxide. There you go. And calcium gets, again, if you've seen all my lessons, calcium gets dissolved into the vinegar. So if you put an eggshell into vinegar, this is what happens. Obviously, usually, unless you leave it for ages and ages, then you still see some eggshell. But if you left it for like weeks and weeks, eventually it would disappear because all the calcium would dissolve. Now, so this is lovely, isn't it? Because it shows you really clearly what happens. But you can't possibly do this if you work in chemistry every time. So you could write a word equation let's come back to this equation again. We did see this last week. So this is methane reacting with oxygen coming out of your gas oven. Here's the word equation. This is a particularly terrible word equation, isn't it? Because water doesn't tell you anything. It doesn't tell you anything about what the particles are in there. Carbon dioxide a bit's better because at least you can see it's got carbon and oxygen in it. But what chemists usually do is write these lovely chemical equations. Isn't that just so much easier and much clearer, really? So methane, the formula for that is CH4, and that tells you that it's one carbon atom with 4 hydrogen atoms, and that is the molecule. This one is interesting because here you can see that the molecule is pairs of oxygen. So the molecule that is reacting is 2 oxygen atoms, but there's 2 of them. There's 2 oxygen molecules. Carbon dioxide, CO2, and then again, H2O is the formula for water, but you've got 2. Nice simple example for you. Carbon plus oxygen goes to carbon dioxide, and that's showing you what happens to the particles, and this is showing you how it works. I want you to imagine, this is not actually true, imagine a chemical reaction between chocolate and marshmallows. Should we get a little plus sign and a goes to sign? Imagine please that if you react chocolate with 2 marshmallows, you get a new product, which is called, let's say if you're using sweets, then the new product is called Swockalot. I have to say, I did not make this up myself. I got this from a wonderful teacher of Tez, who gave her ideas for free. Chocolate plus sweets becomes Swockalot, okay? Can you write me a chemical formula for Swockalot? So our chemical formula for chocolate is a C and an H. And let's say that our chemical reaction, our chemical formula for sweet is a S and a W. Then that would become, what would that become? We've got 2 sweets there, so let's put a 2 there. 1 cube of chocolate plus 2 sweets would become Swockalot, which is a molecule, so that would be CHSW2. Can you see the difference? So here the sweets are just loose, it's just 2 sweets. But here the sweets are all part of the same molecule. So it's not 2 particles of, if we wrote this for example, that would mean that you had 2 chocolate and sweet molecules, but that's not what we want. We want to say that that's all one molecule. So we're going to use this one. Okay? Now, this would be the chemical equation as well. Okay? So the word equation would just be chocolate plus sweets becomes Swockalot. Lilia S'mores, thank you, that's what I'm doing after this. But this is the chemical equation. And can you see, again, hopefully it's a bit more easy to see here, that it's balanced. So you've got 1 chocolate particle on this side and 1 chocolate particle on this side. You've got 2 sweets on this side, and they've bonded to 1 piece of chocolate to become 1 molecule. There you go. So 1 chocolate and 2 sweets on this side, 1 chocolate and 2 sweets on this side. It's just like this carbon dioxide reaction, isn't it? Carbon reacting with oxygen to form carbon dioxide, CO2. I'm going to give you a few examples of this to do yourself. See if you can balance these equations for me. So you need to find what number you put there and there and there and there and there to balance these chemical reactions. Definitely not eating the marshmallows. So you need the same amount of particles on this side as on this side. So for example here, there's 2 sweet particles, but at the moment there's only 1 chocolate particle. And here there's 4 sweet particles. So what number can you put there to make there be 4 sweet particles on this side? Right, shall I show you the first one? So we need to balance this equation here. We've got 1 piece of chocolate, but we've got 4 sweets. And that is becoming 1 piece of chocolate with 2 sweets. That's just not going to work, is it? What would we have to add if we were if we had a smocolate factory and we wanted to make the most swocolate that we could? What would we need to do here? Well, we would have to write a 2 in front of the chocolate. So now we've got 2 chocolates reacting with 4 sweets, and that makes 2 swocolates. So the answer to this first one is, if you add 2 chocolates, then you get 2 swocolate pieces coming out. So have a go at those last 2. Right, let's do the second one. So the second one, you've got 3 pieces of chocolate. You've only got 2 sweets. Oh, I didn't even tell you how many sweets. And that was making how many swocolates? It was making 3, wasn't it? It had to make 3. If you've got 3 chocolates on this side, you need 3 chocolates on this side. And if you've got 3 chocolates on this side, then how many sweets have you got? You've got 6. Well done. I think somebody said that. So the answer to the second one is, you've got 3 chocolates on this side, so you put 3 chocolates on this side, but then because that is a sweet molecule, you've got 3 lots of 2 sweets, so you've got 6 sweets. And oh my goodness, I need so much chocolate to do the last one. Life is just unbearable. I actually can't do it because I ate some chocolate last night. But hopefully you can see that if you've got 5 chocolates in this side, you need 5 chocolates on this side, and then you've already got 2 sweets with every sweet molecule, but you've got 5 of them, so you need 10 sweets. There you go, folks. That is the end of our chemical reactions lesson. Thank you so much for joining me. It's the last week next week before the half term, so I can't decide whether we're going to make shortbread or do the science of bubbles, because they're both going to be pretty cool. What do you reckon? Bubbles or shortbread? You want to make shortbread? You want to make bubbles? Learn about the science of which one? I think maybe shortbread would be good because it involves a lot of chemical reactions that we can talk about. Yeah, let's do that. And then after half term, I'm going to be in my comfort zone and we are going to do a little bit of physics. So yeah, thank you so much for joining me. If you enjoyed that, please do come to my science show on a Thursday at 6 or repeat it again on a Sunday at 9:30. I am doing a science-themed pantomime just live in this same place here on the 21st of December as well, and the invite is up for that. I can't do these unless I get paid for them now, so if you can afford to and you would like to, you can go to my Patreon page. Alright, people are saying shortbread. Lynn makes a very good point that you can eat shortbread. Alright, excellent, yes! Okay, so we're going to make shortbread next week. You only need flour and butter and sugar. It'll be simpler than this lesson. Yeah, if you go to my Patreon page, then you can sign up to support me with £3 or £5 or £10 a month. And this is the first one. The second one is nearly out. I write a bi-monthly magazine, and this next one coming up so soon is on Guy Fawkes. So it's got like quizzes and puzzles and colour. It's like proper. It's got cartoon. I'm doing it properly. It's a proper science magazine. £5 a month gets you that, and any amount gets you some cool rainbow glasses I found. So this month is a good month because you're going to get a magazine about like bonfire night Guy Fawkes, and you also could get some rainbow glasses that you can watch the fireworks through. So if you sign up now, I'll just put them all in a package for you. Or like my Facebook page, or please just tell everybody about what I'm doing and share the news, because I really appreciate you guys turning up every week. It really makes me feel good, and it's lovely to be staying in teaching. Oh, Lynn, you love the magazine. Oh, that's great. Bastian says, could you do bubbles another time? Exactly, Bastian. I think I can almost make bubbles like physics. So we'll do bubbles after half term. Why don't we do shortbread to start half term and then do bubbles as soon as we get back? And that'll be something to look forward to after the holidays. Bastian, you sorted it out. Thank you very much. Right, folks,